If I go to something like this guy, it says a tomato plant needs a circular cage around it in order to grow properly. A gardener makes this cage by bending a piece of wire fencing into a circle. If the tomato plant grows to an approximate diameter of 12 inches, how much fencing is needed? And so when you think about the situation here, so I want to bend some metal fencing around a tomato plant so it can grow, it has some stability. And so what happens is I'm taking a flat piece of fencing to start. So let's say here's my piece of fencing. And I want to bend that, so I want to bend it this way into a circle. Okay? And what happens is if I take those pieces and start to bend them into a circle, this length of fencing right here, well, that becomes this distance around the circle. So in other words, whatever length of fencing I use, well, that's essentially going to be the circumference of my circle. You could also think about it backwards. You could think about it this way. Say, hey, if I start with a circle of fencing, so here's the fence. If you were to kind of lay that out flat, that's the length of fencing that I needed to start with, okay? And so when we talk about the length of the fencing and the circumference of the circle, we're talking about the same thing. And so for this one, if the plant is going to have a diameter of 12 inches, well, I need to find the circumference here. That's 12 pi. So if we're talking about 12d, or you could do the 2 pi r, the radius this time, the radius would be 6, and so then once again we plug it in. And we just actually calculated this a little while ago. If we plug this into our calculators, we get approximately 37.7, and that's going to be in inches this time. And so basically what it's saying is, hey, I need to start with a length right here. This guy right here has to be 37.7 inches. And then when I bend that into a circle up here, well, that'll give me a diameter of 12 inches, okay? Because now I have the proper circumference to make that circle happen, okay? If I look at this guy, it says a 2-foot wide track has an inner diameter of 8 feet. If a cart is placed on the track, how much farther will the outer wheels travel in one rotation? And so a 2-foot wide track has an inner diameter of 8 feet. And so if we kind of think about a track, okay? So a track basically kind of looks like this, almost like a donut, okay? So this is my railroad tracks or whatever. Maybe it's a model train, something like that, okay? And so when we look at this thing, really it's 2 circles, and the 2 circles have 2 different diameters. So what it's saying here is this first diameter, the inner diameter is 8 feet. But if it's a 2-foot wide track, in other words, over here, this is 2 feet. And over on the other side, this is also 2 feet. Well, let's talk about the diameter of the entire thing. The diameter of the outer circle, then, it's a little bit of segment addition. The diameter of the outer circle is actually 12 feet because it was 8 feet to start, but then 2 feet on each end for the width of the track. Okay? And so what it's asking me, when you think about what happens here, so if you think about this situation, as a train or whatever travels around this thing, the inner wheels, as it goes around, travel on this circle. So the distance they travel is the circumference of the inner circle. But the outer wheels, well, they're on this bigger circle, which means in one rotation, they're going to travel farther. The distance they travel is the circumference of the outer circle. And so the question is, well, how much further do the outer wheels travel? Well, I need to find the circumference of each. And so here I would say, okay, the circumference of the inner circle, well, let's see, that's 8 pi, and I can plug that into my calculator. And I'm just going to use 3.14 from here on out. That's feet. And now I have to do the outer circle, so the circumference of the outer circle. Well, that's got a diameter of 12, so 12 pi. And again, I'm just going to use 3.14 to make life a little bit easier. And I'm just rounding each of these to 1 decimal place. The question now asks, it says, hey, how much farther did the outside wheels travel? And so when you look at this thing, yeah, the The outside diameter gave me a bigger outside circumference, so I just need to subtract these. I'm going to take the 37.7 and I'm going to subtract the 25.1. And when I do that, it gives me a total of 12.6 feet. So how much further did the outside wheels travel? Well, 12.6 feet. And that's important because what's going to happen is obviously the outside wheels are going to wear out probably faster because of that greater distance that they travel.